everyone. My name's Tim Kington, and this is Coding is for the Birds. Daisy and I are working through the advent of code problems from 2021, and this is day 7. All right, here is our problem. A whale is going to eat our sub, and we need to break through a wall in a cave system. We're given the horizontal position of each crab, and we need to get the crabs all lined up so that we can break through the wall. And we want to do this with minimal fuel. All right, so what's the minimum position where we get lined up, I guess is the question. All right, so if we read in our line of crab positions, we can loop through these. Let's create an array, or a list, I guess. And let's fill this up. And then I guess we're going to loop from, I suppose, 0. Let's see, my input goes from 0. There are no negative numbers. I don't think there are any numbers over like 1100 or so. Well, 1300's in there. I don't see anything over 10,000 anyway. I guess we can just, we'll try looping up to like 2000. I don't think there was anything that high. So we'll consider each of these positions and calculate the cost. So the cost is 0, and then we need to figure out the cost of getting each crab to this position. So for each crab, we need to add to our cost the difference between pause and I, which is our destination. I should probably call that something more readable. Okay, so we'll add on how much it takes to get to that destination. There's our cost. And we'll remember the best cost. So let's have a variable for that. And we'll have the best position. And so here we'll say if cost is less than the best cost, and best cost, and best pause is next. And then here we'll print those out. And this gets initialized to max value. And this can be -1. I think I have about, how many inputs do I have? Is this unreasonable? 4,000. So there's maybe a couple of thousand numbers, and we're going to try a couple of thousand positions. So this is only about 4 million iterations. This shouldn't be that expensive. All right, so 328 might be the best position. Okay. Well, let's try the sample data and see what's wrong. Here we got a cost of 37 and 2, which is correct. Interesting. Okay. Maybe I just missed a large value in here somewhere. Let's see, should I guess at the range? Should I just figure it's not 10,000? Let's just try 10,000 real quick and see if that was what I did wrong. Still 328. Interesting. Oh, geez. Okay, it's the cost that I needed to put in. All right, part 2. Yeah, now the cost is changing by how far the crab has to move. Okay, so first step costs 1, second step costs 2. Basically, they're the triangular numbers. So it would be 1, or not, yeah, triangular numbers, 1, 3, 6, and so on. So it's going to be n times n plus 1 over 2 for each one. Yeah. Okay, so let's change our function here. It's going to be, this is our distance. And then this is going to be distance times distance plus 1 over 2. Make sure, I guess that was going in the right order anyway. And that is still the same. We're going to have integer overflow, aren't we? Yeah. Okay, maybe a long is big enough. Maybe we have to get fancier. This is a long. Okay. Okay, that looks like a possibly reasonable answer. Okay. So this one's pretty simple. There's really not much to it. One thing that was nice is I happen to know the formula for adding up numbers from 1 to n. So we could have written another loop here, though. We could write a loop that goes from position to destination. That gets a little more annoying because you might have to go from left to right or right to left. But if we just know the formula, we can get the distance and then plug it into that formula and get the cost. Well, that turned out to be a quick one. And I guess that's a reason to remember a few of those old formulas from math class. We'll be back for day 8. Don't forget to like and subscribe.